Today's review lesson involves computing in integers, in other words, how to add, subtract, multiply, and divide positive and negative numbers. Last year in 7th grade math, we played with materials, specifically checkers, to really get the concept into our brains. This year, I'm just going to review what the rules boil down to, and if you feel like you need more work than that, then we should spend some time together. I'm going to begin with adding and subtracting. Simply, it boils down to, once I see that I'm adding or subtracting, I notice the sign in front of the number and I say, like signs, add. Unlike signs, subtract. Use the sign of the greater absolute value in your answer. Okie dokie. So what does that look like? I don't remember. Good. Okay, so simply, and the most simplest form, if I say 3 plus negative 7, I gotta just say I'm adding. What's the rule? Unlike signs, subtract, because one's positive and one's negative. 7 minus 3 is 4, and I use the sign of the greater absolute value, which just means which number would be bigger if there were no sign, or in checker language, which had more to begin with. If I have 7 negatives and 3 positives, there are more negatives. So that is what wins. Subtraction is a little bit more complicated because one of the things that kids often mistake is something like this. The sign in front of the number is, for all intents and purposes, the sign of the number. So one way to think about this is just to say I've got negative 5 and I've got negative 13. Like signs, add, use the sign of the greater absolute value. Other kids find it easier to just work on the principle that subtraction is the same as adding the opposite. Adding the opposite, what we called slash and dash last year. You can always add, change the subtraction to an addition sign, and make the next number the opposite of what it was. Either way, we get negative 18. One time it's very important, it's not really a choice. If I were to talk about negative 5 minus negative 13, it might look like you've got like signs, but this is important to do the slash and dash first. Now I know that I have negative 5 and positive 13, unlike signs, subtract, use the sign of the greater or the more, that is 13. Sometimes if there are more than 2 numbers, kids like to think about the positives together and the negatives together. Okay, so you might want to think this is negative 13, this is 3, 3 plus negative 13 is negative 10. Okay, that's addition and subtraction. Multiplication and division are also related, but because multiplication has some special circumstances, I'm going to talk about division first. In division, it's quite simple. If I've got same signs, it gives me a positive answer. If I've got different signs, it gives me a negative answer. Okay, we always use a fraction bar, or almost always in algebra, so it's pretty simple to spot. You just have to divide as you always would. Let's say I've got negative 56 divided by 8. This is a division problem. You want to ask yourself, what's the operation? Division. What's the rule? Different signs equals a negative, so I know it's going to be negative. And then 56 divided by 8 is 7, so the answer to this is negative 7. Notice that I use different words here. I call this same signs positive, different signs negative when I'm talking about multiplication or division. and like signs add, unlike signs subtract. That's just to help you keep track of, whatever it is operation you're doing, so that you can, if you're the kind of person who has to use your language skills, you can memorize and you'll have different words. That's pretty straightforward with division. Multiplication, it's based on the same idea as division, but the problem is it's possible to multiply three numbers, well, not necessarily at a time, but for example, if I look at this, if I say -6 times -8, I can say, okay, I'm multiplying two numbers. So when I'm multiplying two numbers, the same rule for division applies. Same signs gives me a positive answer. The problem becomes when you have more than that. If I say -2 times 3 times -4, if I'm working with the idea of same signs positive, different signs negative, it would say that this answer is a negative, but in fact it's not. Because if I do these two numbers at a time, I get -6. And -6 times -4 is actually equal to +24. Since we know that any two negatives make a positive, we can devise the rule that works for multiplication, and that is an even number of negative signs equals a positive, because two together equals a positive. And you can even make a positive sign out of the two negative signs together. Like, for example, if I say -3 times -2, you can imagine taking this negative here away. Okay, how do I do my eraser? Oh, yes. Okay, so I can erase this negative, and I can put it here. So then those two negatives make a positive. Just a little trick for remembering. The positives don't matter at all. You only count the negatives. So if I say -2 times -3 times, -4 times 1 times 2. The positives have nothing to do with it. I have 1, 2, 3 negatives. 3 is an odd number, so I know this whole thing is going to be a negative. I also know that 6 times 4 is 24, times 2 is 48, and that makes this -48. An even number of negatives is positive. Okay, so I forgot about an odd number of negatives is equal to a negative, as you've just seen from the example above. This plays into also what happened with exponents. If you remember, if I read this, it's -2 to the second power, which we know means -2 times -2, and two negatives make a positive, so that is +4. This we read as -2 to the third power, meaning if I expand it, I'll get -2 times -2 times -2, and that gives me a negative number. Oh my, not good. Naughty, as Abby would say. So that equals -8. From this, we can derive a rule that's related to the multiplication rule, and that is a negative number raised to an even power. Oops. Okay, you can read that. Power equals a positive. And a negative number raised to an odd power equals a negative. One of the trickiest things in algebra, just to get your eyes used to perceiving, is Not going to be on the upcoming review test because it's actually not, we did do it in 7th grade, but it's not something I'm expecting you to completely have mastered. But if I look at this, as opposed to the problem before, this here is negative 2 to the 2nd power. On the other hand, if I write this, it means the opposite of 2 squared. Since 2 squared is 4, so its opposite, if I take the opposite, that means the answer is negative 4. There is at least one problem in your homework that has to do with that, so I wanted you to remember. Now, if you're working on your homework, or if you're about to work on your homework, you will notice that these are not just straight problems. You always have to use your rules for signs and remember Gram Dass. Okie dokie. That's all for today. I hope that's clear.